Thanks a lot to all the speakers and all the attendees, also those in YouTube that maybe will see this afterwards. I'm really happy to be here today talking about photonics for the food industry. My name is Francesca Moglia, and I'm working for EPIC as laser expert. But today is all about not only lasers, also monitoring systems, also the food industry. So here you can see our agenda. For today, we will start with with me welcoming you. I'm already doing it, and a bit of introduction to EPIC and the two European funded initiatives that we have here today. Then I will give the ball to Beatrice from KMzero. So she will introduce us a bit what KMzero is doing and what it is in general. Then it will be the time for our guest. So really talking into the core of the topics. So we will have Caridad from the Importaco company introducing a bit what they are doing, and then we will try to understand a bit how we can help her. Then there will be the time for the multiple project. First, Roy Mendes, our coordinator, will introduce the project in general, already talking a bit about food industry. Then there will be the time for Ioannis from IRIS, and he will speak a bit more about the application that Multiple is doing for the food industry. And last but not least, then will be time for Andres, as our coordinator of LAMpAS, to introduce what LAMpAS can do also for the food industry, and also, of course, in general for the industry and other sectors as well. Then there will be a few closing words, and then a bit of networking offline. And we will for sure be in time, so well below the 2 hours. Now, just a couple of words about EPIC. The easiest to say what EPIC is always to show our members. So at the moment here, you see all the little logos. We have reached 750 actually members and even more. We are talking about all companies that basically you can see here in the middle slide, dealing with lasers, for example, with lighting, with optics, with detectors. But these are only, let's say, the lower part of the supply chain. But recently, we also have more integrators and also end user of photonics as members. And basically, what EPIC is doing is to promote the sustainable development of this organization and industry, and especially in Europe, and to support the technological and commercial advancement of them. And as you see here on the side, so these red blocks are the things that EPIC are doing that for me are more representatives. So the first thing is technology. We are really taking care that the technology in the photonics, the integration, the utilization of the photonics is improved. And we do it really supporting our members with a lot of services that can be really tailored on their demands, but also on a larger scale, for example, with technology meetings where we really discuss different application of photonics, and we invite the full value chain of the topics to really tackle challenges and build business relationships. Then what we provide is also market data. With market data, we mean EPIC buys some commercial market reports that are really useful usually for the companies, but also since a little bit more than a year, we are really producing special data, the interesting one that is interested for the members, and is really only for EPIC members, and this is really an added value that we recently given to the members. Then we do marketing support. So a lot of my colleagues, they are really working in increasing the visibility of the members, also from social media side, but also with other initiatives like market presentation of their products. So we have really like some events specifically for this, a bit more marketing oriented, but also, in general visibility for the companies that are our members. Networking. So we do events actually in parallel to other famous exhibitions, for example. We talk about technologies, but we also want to bring people together and have the time to have a chat. So networking at any level is possible with EPIC. And then investment. Yeah, it's important. Photonics is usually made by relatively smaller companies. So, and also young companies need a bit of support. So we try always to make a bit of lobbying and to bring together the investors to the possible companies to invest on. Then last but not least, jobsinphotonics.com is a page that we built especially for companies that are looking and striving to get new minds, new supporters. It's really hard, we know, in the photonics world to get good employees. So we are trying here to put all together the pages of the announcement, let's say job offers of the EPIC members, so that also people from outside can get a view of all the possible positions open at the moment. Then last but not least is also why we are here. What EPIC does is to collaborate with other associations. So that is something that bring, in my opinion, a lot of value, because we bring really in this way photonics closer to the end users of different application fields. And today is, of course, food. All these things are possible only because of these little heads on the bottom of these slides. So this is the team behind EPIC, marketing experts, technology experts, market data experts, a lot of efforts all together to cover all the needs that EPIC members have. Now it's a bit to start to introduce you really briefly to the two projects that we have here today for funding from the EU Commission. The first one is MULTIPLE, and it is basically the idea of optimizing the process monitoring, and is all with photonics. What actually will be the final offer will be a full solution of monitoring and optimization for manufacturing chains, but also 5 building blocks, let's say 5 elements and products that can be adapted to also different demands of different end users. So these building blocks involve, for example, snapshot visible and SWIR hyperspectral imaging cameras, laser-based IR analyzers, organic electronics-based spectrometers, multimodal monitoring systems in general, so more also thinking about the controlling of the data, and then as the surface, let's say, of everything, a cloud and edge computing platform to also support the utilizer at the end. Then here the focus area. So we are inside the consortium already taking care of these 3 application fields. Still manufacturing would work in a food industry. Guess what we are talking about today? Food industry. That's why it's really important for MULTIPLE to be here today. And here is all the project partners together, the ways to contact us, and a few of these partners are here today, so they will also tell a bit more about themselves, of course. Then second one is LAMpAS. The surface enhancement inspired by nature project. So it's very nice that we have the opportunity to present also this project. Basically, the idea here is that LAMpAS can really control the topographic characteristics of surfaces inspired by nature. That means all these characteristics, Andres, I'm sure will tell you later, that all these animals or this structure you can find in nature have special functionality. So they can be antibacterial, self-cleaning. You have even also some usually decorative effects, some visual effect. And all this is possible only with the latest technologies that we developed, and LAMpAS is really a big tool with it. We can do really handling at nano and micro scale level of structures with lasers, with fast lasers and fast scanners. And this is possible and interesting for industry only if it's fast and cheap. So that's what we wanted to do. Basically, what the machine will be looking like is like the fifth of this build of these images. I've seen a video recently. It doesn't look yet like this, but it's getting closer to it. Is the full machine that will integrate basically a high resolution multi-beam processing system, a high beam speed deflection, an ultra-short pulse laser that is really the latest generation, fast, polygon scanners really important, an inline monitoring system, so monitoring systems important also for the machine itself, and then of course a lot of simulation and validation processes are involved. But the final machine is the place where we want to go, and this will be soon ready. These are also the slide for us. These are all the partners involved in LAMpAS so far. You can also contact us through these channels. And now I guess I'm done. Also for the people that are listening later on, this is you see my email address there. So in case you're not sure who to contact, you can always contact me. But now it's time to give the floor to all the others. I will finally mute myself as well. And I will give the floor. It's really special. Thank you to you, Bea, from KMzero. Please. The floor is yours. Now I stop sharing.
Thank you very much, Francesca.
There you go.
Yes, so it's nice to be back at one of your EPIC meetings. As you know, at KMzero, we come from the food industry and we invest and support solutions. So one of our solutions is within the photonic industry. But what I wanted to do very quickly with you today is give an overview of why we are trying to innovate in food. So photonics is just a small part of the challenge and opportunity, right? So at KMzero, we work on all of these areas. As you can see, we are researching alternative protein, how to reduce waste, how to innovate throughout the whole value chain of food, reformulating products, and so on. You mentioned that one of your projects is focused on making these products much healthier, also through your technologies. So I really love photonics because it's applicable to many of these challenges. It has a wide range of applications. As you know, we support startups. One of our projects, as I mentioned, is one of your members. So we are very eager to learn more about others. And we also work with larger companies, and we work with the wider community to create that better future of food. But what is the future of food? What I'm going to do super quickly, because I only have 5 minutes, is remind every one of us why we are doing what we are doing, because I think it's a very bold and beautiful purpose, the one we share. So just a quick reminder and taking a step back before we dive into photonics. So as you may know, our sector is one of the sectors that has a biggest impact in the environment in terms of climate change, in terms of use of resources, and we are going through a decarbonization process at the moment. So we really have to keep this in mind when we put forward any solution. We have to think about why we are doing this. So one of the main reasons is because we cannot continue giving that hard time to our environment, also to the health of the people. Some of the solutions that will be discussed today are focused on reducing obesity and other diet-related diseases. And of course, we have a persistent problem of hunger. So there are solutions in the world to all of these problems, but we have seen that the pandemic has made them even worse and more severe. So just to remind some areas of opportunities, I don't mention photonics in particular because I know that it will be widely discussed, but just to open up the mind and to see other opportunities. We are studying how CRISPR technology can also contribute to a better future food as another technology to really conquer our species, right? To edit the DNA in a way that we can create crops that need less resources, for example, or we can create much healthier and more personalized foods. We are also very focused on developing plant-based products that are much better. So for example, this one you can see applies AI technology to combine vegetable sources. And in the end, we get a product that tastes like the one that comes from the animal. So this is very important when we put forward a solution. The taste has to be just as good or even better. If not, consumers are not going to accept the alternative. And also cultivated forms of protein is another very sexy area in the future food space, but it's also very important because it will provide consumers with a very good analog, but we will be able to use very few resources. And other ways of creating these novel products that are more sustainable and more healthy can use technologies such as fermentation. This is a super broad topic, so I'm not going to go into this, but you can take a look at Solar Foods, for example, to see what they're doing. And without food, they have managed to create the highest quality of protein. So just to share with you that there are many things going on in the food tech industry outside photonics that are very, very exciting and that can really give us the chance to really have a very positive impact in the health of the environment and people. Also working on reducing and revaluing waste throughout the whole value chain, also in terms of packaging. also different types of softwares. This is a bit closer to your area of work. This one, for example, is very important in terms of food safety, which, as you may know, is one of the top priorities in the food industry. And we are also researching new personalized foods that will be able to give us superpowers. So this was my presentation, super quick, just a snapshot to give the floor to the other speakers and to dive into photonics. So thank you, Francesca, and everyone here today.
Thanks a lot, Bea. That was a great introduction. Exactly as you said, a little bit of everything, but not too much, so that you tease a bit the attendees with all the possibility that the KMzero is offering, and also, yeah, all the spectrum of all your members. Let's say some snapshots were really interesting. So do you have questions in the room? I didn't say it before. I just said before starting the recording. Please feel free to raise your hand if you're here in the big room, or to ask questions also in the chat, because this is all open for questions. So one thing, if there are no questions, one Bea I have to ask you. I have to say, it's true, you call it the sexy topic, the one of the artificial meat. Can you maybe specify a bit from what you heard so far from the companies that are involved in this, how this market is going? How is it really be possible to get it really eco-sustainable? Can you give us a bit of the opinion from the, of course, companies side, but also from anyway the community that you are representing?
Sure. So yes, this alternative meat space is very exciting because, as I said, we can put forward products in the market that will need less resources, and we can create, for example, a steak without using any medicine for the animals and all the land use and so on. So it could potentially be great. Of course, we are working on the scalability of this issue. So there are like 3 scenarios. We have plant-based protein, which is very feasible, and using technologies such as AI, we will manage to get very good products that taste well and that have a good texture. Fermentation is a plus, so it will be plant-based, and with the use, for example, of fungi, it will be very possible to create very, very delicious and healthy products. And the last one, the one that you called fake meat, it can be actually very clean meat, because what we are doing is creating in a bioreactor a muscle. In the end, meat is like muscle tissue, which is extracted from the actual animal, and then it can be put forward in the market. So Singapore and Israel are the most advanced countries in this sense. In Israel, there's already a restaurant that is serving this type of chicken, actually, and it's a space where consumers can start to interact with this novel product. In Spain, for example, we think that it's going to be in the market in 2024 or so, and there are huge investments going forward so that we can speed this process up.
Sounds very exciting. So, and then you gave us a bit also some details on the technology there, and that was really good to know. So guys, do you have some question for Bea? You see, she's really well informed also on the companies. In case Bea stays anyway with us, and now we maybe go on and we can discuss later with Bea anyway. So thanks a lot for your introduction, Bea. Let's of course keep in touch. We will for sure. Now it's time to give the floor to one of your members, one of your basically representative of the food industry. So it's really a pleasure for me to have here Caridad today from Importaco. Thank you, Caridad, for being here. And please, the floor and the attention of everyone goes to you.
Hello, everyone. My name is Cari Barbera. I work at Importaco Corporate Quality Department. I am a lab manager. Let me introduce Importaco's company. Okay, sorry.
Yeah, next. So Anna, next.
Sorry. We are going to deal with these 5 points. Next. Let me introduce Importaco's company. Our group is based in Valencia, Spain. We have 17 production centers in Europe, and the main business lines are food and natural drink. We have an extensive presence in the retail industry and food service markets. In the Spanish retail market, we develop our business as suppliers of Mercadona. In the Spanish retail market, in the international retail market, we operate with Besana, and in the food industry service and industry markets through the ITAC professional brand. Also, we have 4 mineral water springs. Next page, please. Importaco quality department works under 360 degrees model. Quality focused on 4 ways to make quality: preventive quality, corrective quality, exploratory quality, and predictive quality. The number 1, the preventive quality. Please, next page. Our object is to protect public health and avoid food safety crises. The number 2, corrective quality, it focuses on improving processes by taking the information received from the process control. The 3, exploratory quality, research new technologies to solve challenges. And 4, the predictive quality, apply big data methodologies to model products' behavior. Next, please. Importaco have a technological center. This facility was built in 2018. 55 people were there developing quality controls, improvements, and new products. Next. In terms of quality, we control every product we supply. The 25% of control is measuring food safety to prevent health alerts and protect our customer health. The main problems in the product, mainly in raw material, are foreign materials, raw material defects, mycotoxins, pathogenic bacteria, and new emergent contaminants. Next. The challenge we propose Importaco propose to photonic science is about the designing of a system that allows controlling online process, obtaining agile results, and that allow us to recheck the product immediately, and we are able to work with positive liberation. The proposal, we are looking forward to an analytical device to do multi-parametric controls. That is, for example, having test kits that with a single preparation and a single measurement allow us to know several chemical and microbiological contaminants on the product. The mainly mycotoxins control, the study of mycotoxins is in raw material and product is very important in nuts and dry fruits because they are carcinogenic. Every day there are more legal requirements to comply with, and these limits are now lowered. We need to know in advance the maximum information, aflatoxin, DON, Fusarium, alternaria species. And the second one is pathogenic bacteria and virus. Microbiological control on surfaces and product is very important for the health of our product. Microbiological tests require many hours of waiting to get confidence results. We have to know the presence of Salmonella, Listeria, E. coli steg, and enteric virus. That's all. Thank you for inviting Importaco to participate.
Thank you very much. Thanks a lot, Caridad. Then we can maybe stop sharing, Anna. Thanks a lot. Thank you. Thank you for being here. So you know what happens when you enter in the EPIC world? That you will get the EPIC questions, Caridad. So you already said a bit of interested in from your side. What we usually ask is, what can you do for them? And what can they do for you? So you already proposed what the Importaco is doing, and also really tackled the technology that you would like to now integrate. So let me rephrase it a bit. So you would like to have mainly a control part of the quality. So let's say just on the higher level, but also a possibly preventing the contamination, right? These are two ways that one could pursue. Is it correct?
Yes, we like to control raw materials, but we have to control the facilities. And the problem now is to have a result, you need 24 hours or 6 or 7. But we need online results because we have to recheck the batches.
In time, yeah, sure, I understand. Yeah, that is, then you're in the right place, Caridad. Online process monitoring. So that's very good. I see Lars probably wants to ask also something related to that. Please, Lars, ask your question yourself.
Thank you. Are you using already photonic technologies like spectrometry?
No. We saw the product with Sortex machine, but I think we haven't got any tool in photonics science.
Okay. So it's mostly chemical and all offline, I understand.
Yes.
Yeah, but then Lars, tell them what you can do.
We have developed an NIR sensor, which is capable of detecting signatures very well. It's a revolutionary technology. And let's have a look. Maybe we can do something for you, because especially in food, agriculture and food, we have a lot of applications. We can tell the difference where coffee, for example, comes from. And coffee is coffee. I mean, and telling the difference where it comes from tells you already how sensitive our sensor is. So have a look at Multispectra, and I would like to receive your contact details to discuss everything.
Okay.
We will. So in case you don't do it yourself, please keep us in mind. You can write me an email, and I will establish the connection. So that's why we are here. Thanks a lot, Lars. And that is, you are one of the providers of such devices. Is someone else in the room that I know you are there who wants to maybe tell or ask a question or propose something to Caridad? I know that the multiple and probably also LAMpAS can offer something to them, but that's it. We hear about that already later. So if it's not the case, you're still shy. Anyway, Caridad is with us, and please, Caridad, now listen to all the next speakers, because they have also something to, let's say, keep you excited and get you excited with. So thanks a lot now, Caridad, for the talk. And now let's start with the let's say the projects that we have here in the room. So we start with multiple. So it's my pleasure now to give the floor to Roy, that is our coordinator from AMEN. And I see you're muted yourself, so you're ready to go. The floor is yours, Roy.
Yeah, thank you, Francesca. Hello, everybody. Okay, so can you see the screen?
Now, yes. All good.
Okay, thank you. Okay, so Multiple is a collaborative project funded by the European Commission under H 2020. We are in the 3rd year of the project, and the main aim is to develop a multispectral scalable monitoring solution for optimizing different processes. The main target technologies are these 3 kind of spectral sensors. So we are developing snapshot hyperspectral cameras ready for pollen production, organic electronic-based microspectrometer, so very cheap solution with no moving parts, no diffractive optics, ready for material sensing. And finally, laser-based spectrometer for gas sensing with very high sensitivity. On top of that, we also develop an edge cloud infrastructure to allow the translation of the raw sensor signals into valuable parameters about the process. So regarding the novelty of these snapshot cameras, so the main difference of a hyperspectral camera with respect to a normal RGB camera is how they sample the spectrum. So instead of having 3 wideband channels like RGB, these hyperspectral cameras sample the spectrum in very narrow and contiguous band. So instead of 3 channels, we can have tens or hundreds of channels. And we create this hypercube or chemical image. So for each pixel, we have the spectral signature, which is different from different materials, and we exploit this information to obtain chemical information about the composition of the material. So there are different technologies to implement hyperspectral cameras. The standard ones use any kind of scanning, so we need a movement of the material with respect to the camera, or we need to perform the scanning in the wavelength domain. The cameras developed in multiple are using spectrally resolved detectors that have the filter on top of the chip, so we can create the hypercube in the same instant without diffractive optics. So these kind of cameras have intermediate spectral and spatial resolution, but are really compact, reducing the cost, and allow the acquisition of the images without moving the object. So with these sensors, we cover a wide spectral band from the visible to the far infrared. And with this information, we aim to extract different parameters about the processes and product like composition, texture, color, shape. We are targeting 3 different areas in the project: steel manufacturing with a rolling mill, woodworking with a furniture manufacturer, and in the food industry with a chocolate producer. So in this case, the end user is Jotis, which is one of the major food companies in Greece. And they have a really wide portfolio of products, from baby food, bakery products, chocolate, or desserts. Just a showcase application we are working here in IMEN is the evaluation of the glossiness of the chocolate sprinkles. So these sprinkles are used to decorate cakes and dessert, and it's really important to have a really good visual aspect. So the final step in this process is the panning, where these sprinkles are placed on big tumbles, rotating, and there is one operator that supervises the process and provides different coatings to this chocolate until they reach the optimum stage, final stage. So this is done visually at the moment, and what we try to do in multiple is to have an automatic system to check this glossiness. For that, we address this as a classification problem, where the operator would put this sample on this kind of light cabinet, and it will automatically classify the sample in 6 different stages of the process, depending on the glossiness. We have done some experiments at the laboratory here in IMEN, so Jotis provides us a complete set of samples using different chocolate mixtures and with different glossiness from different production stages. We collected some data sets using a hyperspectral camera developing the project in the visible range. And we can see that the spectra is quite different depending on the production stage. However, in order to obtain a more robust classifier, We also want to exploit the texture of the images, which is very characteristic on these samples. So we combine a texture descriptor together with an SVM to perform the final classification. And from this preliminary test, we obtain 100% accuracy in this dataset. So we think this is very promising and we are reaching good discriminating capabilities. So thank you. This was just a brief summary. So if you have any question, please go ahead.
Thanks a lot, Roy. Thanks a lot for the introduction and also for the extra work on the food industry part also from Ayman's side. I have a question. Maybe you can stop sharing the screen, Roy, so we go back to the room all together. So the device that now you showed also like in a very nice way is based on an offline measurement, right? So this would be a separate device where you can classify in 6 levels basically the sprinkles. Is it correct?
Yeah, this is correct.
Yeah, but do you see some potential for application that can be done really online in maybe in a future line, or also for Yotis General, or where are there maybe the challenges?
Yes, of course, we can work online. We are actually working online in the other 2 use cases, in the steel working and the woodworking use case. In Yotis, I think Iris will show later some other applications where they're working online with the spectrometers we developed in the project. In this specific application, it was difficult to integrate a sensor in these tumbles where the sprinkles are rotating. So we just decided to use this approach. And this is something very similar how the operator works nowadays. So he takes a cup with some samples, do the visual inspection, and then decides what to do. So we just want to do this in a more objective way.
I see. Very good. Thank you. Thanks a lot, Roy. Now to Caridad. Did you see anything that maybe for Importaco can be also relevant? Because this glossiness measurement, yeah, it's very specific for chocolate. It's something that we hear often from our end user in Greece. But do you have something at Importaco also that could profit from this kind of qualification of the food? You're muted. Yeah? No.
I think maybe to control the size of the product.
Yes.
Because we have chocolates.
As well. Okay. So you are also.
And I think it's possible. This technology help us to control the size automatically.
Yeah, automatically, yes. I don't know, Roy, is it maybe you don't need that, right? Maybe it's a bit too much what we have for glossiness for the size. What do you think?
Yeah, probably for the size, maybe it's too much to use a hyperspectral camera, but probably, well, these systems are quite flexible, so probably there are other parameters that could be inspected together with the same system.
Yeah, because basically, Caridad, with such a device, it's an easy one to get the size, but then you can really get also many other characteristics of your chocolate, depending if it's a bar or if it's a praline. So it can be anything can be really detected in one shot, and it can be really just an added value. So the size is one thing, but then you can even have more characteristics out of it. So yeah, this is something you should consider as well with your team, with your R&D team, and we can talk maybe about it as well. But now let's say Roy was already announcing it, so thanks a lot, Roy, for this introduction. Now it's maybe time to go a bit deeper with the integrator working directly with Yotis, our partner in Greece. So it's a big pleasure for me to introduce you, Ioannis from Iris, and yeah. There it is with this yellow background. So the floor and the attention of everyone goes to you.
Hello, Francesca and everyone. Let me share my screen first.
Thank you.
So do you see it? Can you?
Yes, all good. There you go.
Yeah, so my name is Ioannis Kakogyanos. I'm representing IRIS today, and we are here in order to discuss about using photonic-based process monitoring to optimize the process in a chocolate production. Let me see, how can I change slide? Okay, perfect. So this is the agenda. We are going to start with an introduction of the company, a few more words about the near-infrared spectroscopy, advantages and disadvantages of near-infrared spectroscopy, and then near-infrared and food applications, the case study, which are chocolate samples, and then the summary. So we are going to have a lot of near-infrared today. So IRIS. IRIS is based in Barcelona, is advanced technology provider. We are in the market of the food industry for more than 10 years, and we are proud to say that we are among the top 10 European SMEs with R&D projects awarded under H 2020. We have our own family of spectroscopy sensors. We are calling them Visum, and we are mainly using NEAR and HSI. At the same time, we are also having activity in AI and cloud-based applications. And of course, as I told before, we are providers of advanced technical services tailor-made regarding the needs of the customer. So regarding multiple now, the idea of this presentation is mainly to talk about the application of monitoring solutions on how to improve quality control in the food industry and mainly in the chocolate production. For the food industry, the projects of Multiple are mainly about using technology to improve quality control in the manufacturing process by mainly measuring parameters such as viscosity, sugar content, particle size as well, and other quality characteristics of the product. So maybe Caridad is interested in this presentation. So in addition, a combination of the chemometric models that we are developing are performed in order to extract the relevant information and use this analysis to predict quality parameters such as particle size, as I said before. So within Multiple, we have mainly used near-infrared spectroscopy technologies. The diagram here shows the electromagnetic near-infrared spectrum, which is in a small region in the electromagnetic range from 780 to 2,500 nanometers, which is a part of the IR spectrum, actually. IR spectrum consists of the near from 780 to 2,500 nanometers, the mid-infrared, which is 2,500 to 50,000 nanometers, and then we have the far IR, as it is called, which ranges from 50,000 nanometers up to 1 millimeter. Just a moment. Yeah. So here we have the near-infrared spectroscopy, which involves interactions between light and material. IR radiation is absorbed by material only at a certain wavelength. These wavelengths that are absorbed correspond in their frequencies to molecular vibrations such as stretching, bending, wedging, and twisting. Spectra in the near result from energy absorption by organic molecules and include harmonics and combinations of harmonics that originate from fundamental bond vibrations that occur in the mid-infrared, the MIR of the spectrum. Most of the bands occurring in the near range are attributed to functional groups containing a hydrogen atom, usually. So then we have the near-infrared spectroscopy that has several advantages over other types of spectroscopy and is therefore a technology that is preferred in many situations. For example, near technology allows rapid analysis in real time, and several parameters can be analyzed simultaneously. Another advantage is the near, which is cost-effective compared to other spectroscopy techniques. Even high throughput NearInfrared is non-destructive and requires little or no sample preparation. It can also be used to analyze multiple components in a single scan. The drawbacks, on the other hand, of NearInfrared include its low sensitivity. So we have this issue with the sensitivity here because of the overtone and combination modes and the large number of possible vibration. NearInfrared spectra are very complex and consist of many overlapping peaks that result in broad bands. This of course makes it difficult to visualize the interpretation of NearInfrared spectra, to assign certain features to specific chemical components, or to easily extract the information contained in the spectra. So despite these limitations, NearInfrared is let's say, undisputed path monitoring technology because of its ability to combine different quality attributes like chemical, physical, and biological, let's say, attributes, as I said before, into multivariate quality indices. So, and then we have the near-infrared and food application, which is about the quality of the chocolate. This plays a major role in the sensory evaluation, let's say. Several projects have been developed in a fast and non-destructive method to predict the quality of chocolate based on physicochemical data sensory properties using the 5 basic flavors. We were involved in the development of near-infrared spectroscopy for quality control. So what happens mainly is that the particle size and shape analysis is immensely important in the grinding of cocoa and in the production of chocolate and related productions such as chocolate mixes, fillings, cocoa butter, and many more. The reduction of particle size takes place in the refining stage to obtain the optimal size of the particles, which is important for the texture of the chocolate. In order to obtain high-quality products, viscosity is considered an important physical parameter in the production of chocolate and cocoa products. Of course, it influences the textural properties of the chocolate. Also, acidity, sweetness, bitterness, color intensity, hardness, and smoothness are the most important parameters that are being influenced. So in this section, we present the path technologies that have been researched from multiple projects. The first is the technology that was developed during the projects. At the same time, a commercial device was also investigated to compare the results. The 2 spectroscopy sensors are in the short wave infrared range from 700 to 1700 nanometers. But what is the difference is that they differ in the spectral resolution. The multiple devices have a lower spectral resolution compared to the commercial devices. Here you can see actually the multiple technology integrated prototype and the Visum in line, which is from our family of products. So the 2 sensors have been used to collect data to estimate viscosity and particle sizes in the chocolate samples. Chemometric modeling was developed to observe the correlation of the signal which has been acquired from the instruments with the reference values of particle size and viscosity. So in the table 1, we see the results of the chemometric modeling. When comparing the 2 instruments, the multiple instruments show promising results. The determination correlation gives a value above 0.8, which means that the spectral signal obtained from the signal, which is correlated with the reference values for the particle size. Furthermore, the prediction errors are lower with values of about 12 microns. And this is a summary. So in order to summarize, we have 2 monitoring devices for the application of near-infrared spectroscopy in food. Shortwave infrared is useful for determining particle size and viscosity in chocolate, combined with chemometrics to extract relevant information. And that's all from my side. Thank you very much for your attention, and I'm open for any question.
Thanks a lot, Ioannis. Thanks a lot. So Caridad, you heard now we have even something that measuring the particle sizes. So maybe not the microscopic one, but a more microscopic one. And thanks a lot, Ioannis. So there
and
is
much
already
more. We have viscosity here.
Yeah, and viscosity. Yeah. But that's what the guideline for Caridad. We can do something, but always with more in one device. So that is the added value. Caridad, is it something that resonates with you as well? What Ioannis was telling us.
I think the proposal is interesting. I know new technology yet because we use to measure amygdalin in almonds, and we have a study to study amygdalin because amygdalin is the chemical who do the almond bitter.
Ah, okay, yeah.
And we have to control the quantity.
So the amount of bitterness in every
Yes.
almond. Okay, I see. Okay, and this is something that you would like to. Is there someone in the room who has experience already with this? Please feel free to talk with Caridad, to raise your hand. In the meanwhile, we have Ian that has a question to Ioannis. Please, Ian, if you can introduce yourself, and then you can ask a question directly to Ioannis. Thank you.
Hi, good afternoon, everyone. Thanks very much for a nice presentation there, Ioannis. I had a question on something you mentioned there, which was to do with a problem that you see as being the overlapping of all these bands in terms of what you're looking for. And the question was, do you use optical filters within your systems to try and isolate the bit that you're looking for?
Yeah, I'm not sure if I can reveal on how we are doing that, but for sure this is a matter of the chemometric models that we are using. This is also a purpose of multiple, that we have a technology. We are trying to, of course, let's say, improve it. And since we have some chemometric models with computational, let's say, techniques, we are trying to, those chemometric models, to try to make analysis in a kind of, let's say, layers.
Yeah.
You see what I mean?
Yeah. I mean, what I'm talking about is actually measuring it whether it's the amount of glucose or you know, whatever sugar or protein or fat, actually measuring it directly in line, you know, avoiding a lot of you know, so that it's an instant result. I mean, these sort of technologies already exist.
Yeah, maybe it's something that we should look into it.
Yeah. Okay. we'll maybe talk more afterwards.
Yes, why not? So, Ian, you are from which company?
Sorry, I didn't say that. The company's Vortex Optical Coatings, and we're based in the middle of the UK.
Ah, okay, optical coatings.
Yeah.
Great.
Thank you, Ian. That was exactly, you see, Ioannis is doing my job now, asking you the company. Very good. So we get the introduction at the end, but that is important. At some point we got it. So thanks a lot. And yeah, Peter, that I was coming to you already, you know, and now you raise your hand. Please, Peter, make your comment or questions.
Hi, I'm Peter Totrup. I'm the CEO of a company called NLIR. We are doing a spectroscopy in the mid-infrared, a little further out. Did you ever try out to use the mid-infrared, the primaries, or to Jonas on your product?
Ioannis,
Not sure. I'm not sure. I cannot really answer this question. Our family of products is based in near-infrared and hyperspectral imaging, but I'm not sure if we are working on MIR. Maybe something that I'm missing.
So I can just share a little screen here. Can I do that, Francisco?
Absolutely.
I'll just share what we do. I think this is the one. So so what we do in our company is we're making these spectrometers, and they are actually extremely fast and very well suited for mid-infrared inline spectroscopy. So we can do up to thousands and thousands of spectra per second. So if you have some inline, this could be a solution. And here you can see some of the measurements we've done on liquids. So if this could be of interest, Jonas, we can maybe offline talk about this.
Sure, we can. Even, I mean, networking is always welcome.
Very good. That sounds
Peter.
good. But maybe we ask Roy also, from your experience, Midair is a super hot topic for Epic. So maybe also Roy can give his opinion, and Andres as well, because Andres and Midair is like this. So, but this I know already. We never talk much about Midair that is not gas sensing with multiple people. So maybe Roy, you can comment on our Midair experience and what maybe NLIR can do for us. Who knows?
Yeah, in Midair we have Aeroptic, which is a company from Poland working in the development of these laser-based gas analyzers. And I think they use tunable lasers at the specific wavelengths where the target compound is. So I think this is a bit different technology.
Ours is
I found this technology really interesting. I was wondering if this can be coupled with fiber optics.
I mean, our product is actually a fiber spectrometer, but just in the mid-infrared as you're used to in the near-infrared and the vision.
Okay, so it seems very promising.
Okay, thank you. So we will connect.
Yeah, because that's true. We consider Midair in multiple only for gas sensing, but that's good that you're here, Peter, that you can throw some ideas, because that's definitely one other part of the spectrum and application of the spectrum that is definitely interesting. So yeah, Caridad, I don't know if it's a bit of another spectrum. I mean, just to tell you what is the Midair technology is looking at other wavelengths, so a bit longer wavelengths. So there you can also discover characteristics of your food that, depending on the food and the things you're looking for, can be also interesting for you. There is definitely some room for consideration also internally. If you want to enter the Midair world, we have a lot of people in the network that can help you. So Peter is one of them, and also others. So feel free to consider this. That's a magic word, Midair. Okay, Caridad, it's just something for you, food for thoughts. That's food for thoughts. With food people is nice to say.
There are a lot of knowledge and something we can do with this technology.
Absolutely, yeah. And yeah, keep us in mind for this, and all our people here in the room, and maybe in the future also will watch YouTube, knows that can come to you, because if they feel like you're interested, then they can use it for sure for this. Yeah, but now, I mean, let's, of course, everybody in the room that still want to talk about detection and cameras, you're very welcome. But now we move to someone that uses the cameras as well as a process monitoring system, and it's a bit different topic. So Caridad, please pay attention, because this is another story that we want to tell you. And the storyteller is called Andres, and is our coordinator of LAMpAS, coming directly from Germany. But yeah, well, the speaking, the text that is also a Spanish speaker, so you will hear it. Thanks a lot, Andres, for being with us today. And the floor is now for LAMpAS and is yours.
Okay, thanks a lot. I hope you can already see the screen.
And yes, and now perfect exactly, there you go.
So yes, we are going to change a little the topic now. The idea is, what can we do on surfaces so that we can get specific functions, and in particular now thinking on the food industry. So how can we mitigate some problems that are related to the food industry? Before that, just let me tell you that we are coming from Dresden. We are working together, the TU Dresden, with Fraunhofer at the US at the Center for Advanced Microphotonics, where we are dealing with these surfaces, how to develop such new properties, and also with laser technology, so that we focus on the development of systems, machinery, in order to provide surfaces, technological relevant surface with special properties. At the beginning of the day, Francesca showed a slide where we have seen natural example. And the idea is that, I mean, there are many surfaces in plants, animals, insects that have some functionality. And many of these functionalities are based on structural elements with, in general, different feature sizes, some of them in the nanometer range, sometimes in the micrometer, sub-micrometer range. And by combining these topographies, this special topographical element, it's possible to have new properties that, again, are just the result on the geometry and size of these elements. And just to mention the one here in the center, this is a very nice example of an animal, insect in this case, that has an antibacterial surface. So this insect had on his surface very small elements, about 800 nanometers in size, which are decorating bigger elements in the micrometer range. And in general, what natural examples are doing is trying to provide mechanical stability to the small elements that get the special function with bigger ones. So in this way, we have even multifunctional surfaces. And what we want to do is to imitate these examples using laser technology. When you are thinking on laser technology, there are many technologies that you can use. The most common is direct laser writing. So imagine that you have a pen, but this is a pen of laser light, and you're just moving the laser beam over the surface. So you melt material, you can ablate material, and in this way you can create a specific topography, like the one here in the bottom. Then there are other technologies which are a little more complex. For example, direct laser interference patterning. What we do here is to put 2, 3, 4 or more beams together. When you overlap the beams, you create which is called an interference pattern. So it's a periodic variation of the laser energy. And this means that you have a kind of stamp of light. And with this stamp, you can directly create these very small structural elements that can be in the nanometer or micrometer range, using, for example, just one laser pulse. And then there are other technologies that are a little more exotic, let's say in the name, laser-induced periodic software structure, where you are here using femtosecond, picosecond laser sources generally, and then you create elements by self-organization processes with dimensions below 1 micrometer. So at the end, we have 3 different technologies that can provide us to create these structural elements I was showing at the beginning with different scales. So in the micrometer, sub-micrometer, micrometer, and nanometer range. And by using these topographies or these technologies, then we can provide surfaces with new properties. And now I would like to show you some examples. So here we have some surfaces that have been treated. It's an aluminum surface that have been treated with the different technologies I were talking before, so that we have topography with different structure sizes. And the idea first was to create a super hydrophobic property, because many equipment, in particular that is related to exchange of heat, you want to avoid the condensation of water, because this has a negative influence in the efficiency of the equipment. So you are using more electrical power at the end. Therefore, by using these structures, what we are doing first, just trying to make the surface to be super hydrophobic. That means that the water is not there, or that the surface is irrepelling the water droplets. This is reached when you get a contact angle, what is called about over 150 degrees. So it was quite easy to do this with the different laser technologies. But the question is, what about the other properties? And therefore, we also were focusing on ice-repellent surfaces. Also, this is something you have in many equipment in the food industry. So you don't want that the water condensates and that gets frozen, because it also decreases the efficiency of the different equipment. And what we observe here, so now we are putting, you will see in the videos, the droplet of water on different surfaces, the reference or the flat surface, and then the surface is treated with 3 different laser technologies. And the aluminum surface is at minus 20 Celsius degrees. So you see now how the droplet starts to freeze. And what we observe that in the case of the different texture surfaces, we have an increase of 100 up to 133% of the freezing time. In particular, we see the highest improvement excuse me, when combining the structure with different topographical elements and different sizes, like in the natural examples. This kind of multi-scale or the combination of different topographies also allows to create, as I mentioned at the beginning, multifunctional surfaces, which means in this case, we can, for example, protect a certain property like the water repellency in the way as the natural examples are doing, where we have bigger features that are protecting the smaller structural elements. And here is the case when we measure a water contact angle on texture after a wear test, so we are deteriorating the surface on purpose, and we see a reduction of only about 5% of the water contact angle, which means that we can preserve these properties together. Other property that can be also very interesting in food industry are related to self-cleaning properties. So when we reach that the droplet of water, for example, or that the surfaces get super hydrophobic, then when you put a droplet of water, it will roll under some angle on the surface. And if you have some dirt, then the water will start to collect this dirt, like in the lotus effect. And we develop also a method where we can quantitatively determine the amount of particles that remains after a certain amount of droplets go through the surface. This animation, actually a video that you see is in slow motion. This in reality takes just some few milliseconds. So then going to larger scales, we also have equipment where we can treat stumps or cylinders, or also slips. And the idea is to create this tool so that we can, by roll-to-roll process, transfer the topography of the metallic tool to the polymer foil. And we are doing this in this machine where we can reach throughputs up to 50 square meters per minute. In this case, for this case that's shown here, it was 1 square meter per minute at very low web speed. And after you do that, then this is how the polymer foil looks like. And what we did now with these polymer foils is to look how is the adherence of bacteria. Therefore, you can see on the left side now of the screen different topographies that we tried with different spatial periods, which is the repetitive distance between the structures that we create, ranging in this case from 1.5 micrometer to 4.3 micrometers. And then we perform a bacterial test, and what we observe, just based on these topographical changes, a reduction of 54% of the bacteria addition. Remember, we are not using any kind of chemical. We are not also affecting chemically the surface. This is just based on a pure topographical effect. So now going to the technology, how can we do this directly with lasers and at large scales and also fast? And there are some options. Here I'm showing one of our last developments of new generation of interference optical heads. In particular, this technology we're working for more than 20 years now. And you can see how easy it is to process a large area of a metallic part. So we make some beam shaping of the laser beam so that we can make the overlapping of the beams with high precision, and also have a very tolerant process regarding the focal depth. And here are some examples that you can see on steel surfaces, how we could create such topographical elements at high speed on large areas using laser. Another example now, and is related to our project LAMpAS, where we are combining the interference technology with polygon scanners. We are introducing also a high power, ultra short pulse laser source with a power of 1.5 kilowatt. There is really a lot of laser power for, for this kind of laser sources. And in addition, we are also including monitoring solutions, because we need to assure a certain quality of the structure we are producing. We need to assure that we make them with zero defect. And of course, we need to assure a certain performance of the surfaces that we are treating. And so we did now the demonstration first of the possibility of combining interference structuring with a polygon scanner. It was done, let's say, first time in the world. And we were using a 400-watt laser, delivering 10 picosecond pulses, working in infrared wavelength. And so what you can see now, depending on the speeds that we are using for scanning the surface, or with polygon scanners, you can very fast, you can even reach 5 kilometers per second today. So here we are changing the scanning speed up to 350 meters per second, and we created these periodic lines at really high throughput on a polymer surface. So it was the first time, as I said before, that these two technologies were combined together. And the good thing is we start to come to throughputs or process speeds that are really close to the requirements of the industry. We have here some drawbacks in this initial configuration, is that the size of the structure is relatively big in terms of lateral resolution, and therefore in LAMpAS we have now the first prototype of a very special polygon system that cannot tell too much what is inside, but is quite complicated. And this provides smaller feature sizes which are relevant for getting functions that are required in very different industry sectors. The next step is to combine the polygon scanner with a high power laser source, and we hope for sure in a couple of months, by the end of the year, we will be finished with the LAMpAS project, that we will also have the chance to develop together with customers and partners in new applications, also in the food industry sector. And with that, I would like to finish my talk, and thank you, Francesca, and for the invitation, and the rest of the participants for the attention.
Thanks a lot, Andres. Thanks a lot. So thanks a lot. Now you got the full picture, Caridad. So that is what I was meaning at the beginning. So we have here in the room technology that can really monitor your things online, even offline, of course, and check the quality, but also prevent or improve basically your devices. So is it something that you heard from Andres that is interesting for you? All these hyperhydrophobic characteristics, antibacterial surfaces. So is there somewhere where we could come and bring these characteristics to your machines? Is it something that is interesting for you? You're muted. No.
I think antibacterial surfaces is interesting for food industry because we have now to control the growth of biofilms, mainly Listeria monocytogenes, and the hydrophobic surfaces too, because I think it's easier for the people clean the surfaces. and our process is a dry process, because the mainly activity is roasted nuts, and the surfaces are dry.
Okay. Is there something
Okay.
you want to comment, Andres?
Which kind of materials are you talking about? I mean, which kind of I mean, the surface of which material should be treated?
Nowadays are steel.
Okay, so typical stainless steel, yeah.
Stainless steel.
Okay, and this is something that we know very, very well.
Sounds good. Very
also,
good.
Also depending on the steel is not the same. There are some chemical elements that also play a role in this superhydrophobic behavior.
Yeah, one thing also that was a bit also interesting me at the beginning, what Caridad was telling, you have a specific also bacteria and particles that you want to avoid. And basically what on a tailored kind of way, also these structural surfaces can try to work on specific molecules, right? So you, Andres, were saying for the antibacterial one, you can do some tests with certain bacterial, but not all bacteria are the same, right? So not all steels are the same, and not all bacteria are the same. Is it correct?
Yeah, it is true. Depending on the kind of bacteria, you may have to produce a different topography, because bacteria, they also have very different geometries and sizes. And it's a play, let's say, a game between the geometry of the bacteria and the size, and this at the end is what we have to consider in order to create the topography that is appropriate for such kind of contamination.
Yeah, so imagine, Caridad, this can be, let's say, of course, I understand you probably want to have like a generally clean from bacteria and viruses. The surfaces, of course, the more the better. But one can consider to understand a bit your environment. What is the most probable particle that is contaminating your machines? And then one can consider how to really design the surface of your machines. And steel is a very good material for us, because it would be the easy one to try. And if our position at the moment, I am the one trying to sell the machine. So Andres is behind the scenes and building all that everything is working fine. I am the one who has to find someone to test this machine. So just to tell you the situation now, we are trying to put together. So we have a partner that is not in the room today, but of course it's in our partnership. They are building the machine, so they are putting all together all the pieces that Andres was mentioning. And our role now is to try to find people who are willing to make a trial. So it's if you, Caridad, are interested, we can discuss also here offline. If we can, for example, provide you with some surface that is already pre-treated in some kind of like superhydrophobic or antibacterial or anything that is more appealing to you. And of course, all the people here in the room and who else will listen to this webinar, same is for you. For stainless steel, we are, of course, easy to go. But if you have any challenge, also other surfaces, Andres' job is also to test different wavelengths, different surfaces. Is very much of an expert. And in the consortium, we have a lot of people really dealing with this since a lot of years. And now we are just trying to get it a bit into the industry for real, and not only on scientific papers or in magazines articles. So that's the time for 2022. So keep it in mind. So Caridad, can we count on you for some offline discussions? Yes. I hope so. And yes, so do we have other questions or comments for Andres? So here in the room, just to tell you, we have some, as I said, people that can help us. Actually, LAMpAS, the process monitoring system, are good directly for the food production, but also for LAMpAS itself. We have ourselves a Midair camera mounted that is online monitoring what is happening in the structuring process. Here, of course, we heard more about the spectroscopy and fiber-based spectroscopy, so it's a bit another tool. But nevertheless, process monitoring is good also for us, for LAMpAS. And then I also think we can maybe make an introduction. I just know here we have in the room deep detection. So Josep, it was maybe interesting to let us know what are your interests in this meeting and what is that you're doing in deep detection.
Okay, can you hear me properly?
Yes, we can see you and hear you. Thank you.
Okay, first of all, thank you so much to everyone for your presentations. And it wasn't planned that I was talking today, so I don't have a presentation.
No, that's okay. No, but just to let us know what you're doing, your interest in this meeting, and if you found some inspiration to work with someone today, that is the important part.
Okay, so we are Deep Detection. We are a startup based in Barcelona, born from a spin-off of the Institute of High Energy Physics of the Autonomous University of Barcelona. And mainly we are dedicated to the detection of foreign bodies, for example, low density objects, an example, plastic inside yogurts, using multispectral X-ray images, and which together with dual energy techniques, we can separate objects. We're able to segmentate objects and extract these plastics from the yogurts, which are a really big problem nowadays in the industry. And what I've seen here, we are not much as help since we don't use spectroscopy or surface studies.
Yeah, but nevertheless, it's something that is useful. Maybe we can find for sure other application and other collaboration for you. So, and definitely, I assume so. Nevertheless, the food industry is something that you are addressing, right? So, like for foreign detection of foreign particles, or that was you were meaning at the beginning. So maybe Caridad can also be interested in this. Same country,
yeah,
also.
Yeah.
Very good. Yeah, thanks a lot, Joseph, for the introduction. And is there someone else? So now we came to the end. We heard of everything that LAMpAS and MULTIPLE can do. Caridad made all the comments that could do about all what we heard today. So if there is someone who wants to say a final word, a final introduction, a final comment, please feel free.
May I?
There is a hand raise. Yes, sorry. You know, Ioannis, you have the raise hand yellow that is on the yellow background. Yeah, okay. And now I've seen it there. It's a raise hand. Yes, sure, Ioannis, please.
I wanted to ask Josep because my connection is not really good and I didn't hear exactly what is the activity of deep detection. Are you technology providers or you have to do something with yogurt, you said?
We provide the cameras. The cameras that are installed inside X-ray machines that allow the users to detect these foreign bodies.
On yogurt?
Yogurt, it could be glass inside beers, it could be wood inside cans.
So they are somehow IP certified and so on?
Yeah.
Yeah, okay, great. Yeah, okay, thanks.
Very good. So now we have more examples. Asking Ioannis, you got from Josep more examples. So it's good for all of us. Thanks a lot. So the question stays the same. 3 to 1, no more comments. If it's not the case, we close here the recording and the meetings. I thank you all really much to the speakers first, to very first to Bea, because she agreed to bring KMzero and also Caridad and Impertaco to this meeting. I thank all our collaborators from MULTIPLE and from LAMpAS. It's really great that we can always organize this meeting where we can come together and see some synergies among the two projects and the activities we do. Thanks a lot to all the attendees attendees, those who were speaking, of course, thanks a lot for also introducing yourself and a bit interacting with the people in the room. All those who were silent, I hope you got some insights and some ideas to maybe contact people later on, or some business opportunities to exploit. And for those who will watch this recording later on, please feel free to reach out to me. Maybe I can be the right one to connect you to the people you would like to talk to. But for the European funded initiatives, you saw the slides at the beginning. You can also go through that connections and to our social media and connect in different ways. So I thank you all very much. And I guess we see each other hopefully soon in other platforms with other projects, with other ideas and other synergies. Thanks a lot, and bye-bye.